In this session, we shall see application of differentiation. So we have a couple of questions we want to solve. This is our first question. Find the gradient of the curve y is equal to x cubed minus 2x squared plus 5x minus 3 at the point where the curve crosses the y-axis. So there are some clues that we need to look out for. One, we are looking for the gradient of the curve. At what point? At where the curve crosses the y-axis, okay? We will understand these things to help us to solve the question. Now, what are we to do? We should find a gradient. So the first thing that we need to do is to find a gradient function, okay? So the solution, we start with the gradient function. Now the gradient function is dy dx is equal to, then we differentiate, okay? So 3 comes down, so we have 3x. Now we subtract 1 from the power. This is 3, so 3 minus 1 is 2. Then 2 times 2, that will be 4, okay? Then we subtract 1 from the power, so we are left with 1. So we have 4x. Then there's 1 here, so 1 times 5 is 5, okay? But x raised to the power 1 minus 1 is x raised to the power 0, and x raised to the power 0 is 1, so still 5. Now, when you differentiate a constant, it's 0. So this is our gradient function, okay? This is our gradient function. But the question is not asking us to find the gradient function, no, but rather we are supposed to find the gradient, okay? So if we are to find a gradient, then it is a number that we are looking for. But this gradient is occurring at where the curve crosses the x-axis, all right? Now, at the x-axis, what happens? So at the x-axis, at the y-axis, x is what? 0, okay? X is 0. So when you draw the xy plane, x and y, all the numbers on this y-axis have their corresponding x values to be 0. For example, if you have a point here, you could call that point 0, 2, okay? So the x value is 0 and the y value is 2, okay? So that is why on the y-axis, all the x values are 0. Also on the x-axis, let's say we have a point here, 5, 0, okay? The x value is 5, the y value is 0, okay? So on the x-axis, all the y values are 0, while on the y-axis, all the x values are 0. Okay, so now that we know that at the x-axis, on the y-axis, the x value is 0, then we can find a gradient. So dy dx, okay, at x equals 0, which means we are talking about the y-axis, is we put 0 at where we find x in the gradient function. So we have 3 raised to the power 0 squared, then minus 4 into 0 plus 5. So all this is 0, this is 0, so we are left with 5, okay? All right. Therefore, the gradient of this curve at the point where the curve crosses the x-axis is what? Is 5. So the gradient is 5. And you are done, okay? Let's see our next question. Find the coordinate. Okay, so we are going to find what? Coordinate of the point on this curve at the gradient 7, okay? So what we are looking for is what? Is a coordinate. Now, when you are looking for coordinate, you have in mind that you are looking for something like this, x, y, okay? So you are looking for the x value, you are looking for the y value, all right? Okay, so what is the first thing that we do? Since we were given gradient, okay, since you are given gradient, then we need to find the gradient function of this curve. Okay, so the curve is y is equal to 2x squared minus x minus 1. All right, so the gradient function is you differentiating this. So 2 times 2 is 4. Okay, 1 minus 2 is 1. Then there's 1 here. Okay, so 1 times 1 is 1. And then x raised to the power 1 minus 1. When you differentiate, the constant is 0. But this will give you 4x. Now x raised to the power 1 minus 1 is 0. Now x raised to the power 0 is 1. 1 times 1 is 1. So this is what you have as the gradient function. All right. But what are they saying? They are saying that find the coordinates of the point on this curve at which the gradient is 7. That tells you that this gradient function is equivalent to the 7 here. So this implies that 4x minus 1 is equal to 7, okay? Therefore, we have 4x is equal to 8. That is when you add 1 to both sides. So x is equal to 2, all right? So this is the x value that you have found. You are left with the y value. So to look for the y value, so to find the y value, or the, let's just call it y value, or the y component of the coordinate, you substitute, okay, you substitute x equals 2 into the curve, okay, into the curve. This means that you have y is equal to 2 into 2 squared minus 2 minus 1, okay? So this will be 2 into 4 minus 2 minus 1. That would be 8 minus 3. Answer is 5. Therefore, the coordinate is x first, okay? Always remember that x first. So that is 2, and then the y, which is 5. And you are done. Let's look at our final example. So this, given that y is equal to this, the first thing that we are told to do is to find dy dx, okay? That means find the gradient function, okay? So dy dx, the gradient function, is 3 times 4 will give you 12, okay? Minus 1 of the power, that will be left with 2. So 2 times 3 here, that will be 6. 2 minus 1 is 1, so you have 6x. Now, this has a power of 1, so 1 times 6, that is 6. And 1 times 1 minus 1 is 0, so x raised to the power 0 is 1, so 1 times 6 is 6. You differentiate this constant, you get 0. So you are done with the first part. Now, the second part, you are told to find the range of values for which x is what? The range of values of x for which your gradient function is greater or equal to 0. So you are looking forward to solving this equation. All right? So this means that, what is your dy dx? This is it. So you have 12x squared plus 6x minus 6 is greater or equal to 0, okay? Well, 6 can go into all, so you'll be left with 2x squared plus x minus 1 is greater or equal to 0, okay? Now, at this stage, I will advise you to solve it as if it is not coming with the inequality. Just solve it as if it is just an equation, okay? So for a small decoy, you have 2x squared plus x minus 1 equals 0, okay? Just assume that is an equal to sign, and I'll tell you why. Now, by factorization, you should have 2x minus 1, then you should have x plus 1 is equal to 0. Okay? This implies that 2x minus 1 is equal to 0, or x plus 1 is equal to 0. So we have 2x equals 1, x equals half, or x equals negative 1. Okay? Now, this quadratic is of this nature. So remember that the y-intercept is negative 6. Let's say the y-intercept is somewhere here. What are the roots? You got negative 1, and then you got half, okay? Half. So the curve would probably look more or less like this. Okay? All right. Now, what are they saying? We are told that it must be greater or equal to 0. Okay? So remember that this is your y-axis, this is your x-axis. All the values here are positive. Okay? They are positive values. And all the values below the x-axis are negative values. Okay? Put that one in mind. Now, when we are told that dy dx is greater or equal to 0, it means the values that we are looking for are positive values. Okay? All right. So if it is positive values, then this is the desired region of the curve we are talking about. Okay? Now, for us to find the range, it means that the x value should be greater or equal to half. Okay? The x value should be greater or equal to half. So that is the first part that we know. X value should be greater or equal to half. Now, when the x values are less than half, you see, you'll be coming to this part, and these will give you negative values. Okay? So this is for the right part. Let's go to the left-hand side. What would the values be? Now, when x is less than negative 1, it means you are coming to negative 2, negative 3, negative 4, okay? When x is less than that, you can see that the curve is above the x-axis, okay? So that means that you are reading positive values. So when x is less or equal to negative 1, all right? Therefore, the range that you are told to look for is when x is less or equal to negative 1 and when x is greater or equal to half, and you are done. Now, a tip for you. It will be best in your own interest to get a sketch of the curve to see where it is positive and where it is negative.